Please welcome Rob Oldaker, Adrian Tucker-Peake, and the MGTF 200 HPD story. Thank you.
Hello there, and good afternoon, and good to see such a massive crowd here to listen to this fascinating story, because that's what it is, and you're missing it if you're not here. The two of us here, I'm Rob Oldaker, and I was Product Development Director at the time, from 2000 until the end of MG Rover, and I was also responsible for the motorsport programs that we did as MG Sport and Racing. Adrian rejoined the company like I did soon after the start of MG Rover, and bear in mind that back in the middle of 2000 the company didn't even have a name, let alone a full product plan for anything. By the time Adrian was there, we were MG Rover, and we did have a product plan which we then dealt with very rapidly. Now some of you may well have read the article in the Fast Forward magazine, and at least got some information from which you might be able to get some questions that you want answered, but we're here to answer those questions as we go through. Now the background to this car is a slightly strange one, because it wasn't a car that sat in the product plan at all, not until later. We had far more important things to do, which was to get the Z cars into production, and the Tourer version of the 75 and the ZT into production. We had the TF to get into production. It was a very, very, very busy time. But the 200 HPD came about as a result of us having a small organisation within my product development group, which Adrian was very much part of as a technical manager. Tony Spillane, who's also on site here, was the manager of that very small group. And really it was a group for kicking around some ideas and coming up with some good ideas and distilling those down to something that we could actually get our teeth into and deliver. And this was one of those projects. Now, that was really starting in around 2002 and went through to 2004. And Adrian's going to talk in far more detail about the program details of how it came about. Now, for us at MG Rover, the sports car was always the important car to have at the top of the range as a halo project that people could aspire to. And very important to me as well, that we had a really good sports car up there. And of course the writing was on the wall as far as a number of things coming at us from government, coming at us from competitors, that would make it quite difficult to do all that stuff. Now Adrian will cover the targets and features of the car, as I've said, and I'll come back at the end and talk about the launch of the car that we did in like 2003. Now at the time, as I say, climate change was becoming a big issue for governments, including ours. Urban pollution was starting to get a press. We knew that we had to do something to get to EU4 with our K-Series engine, which was not an easy project, and it also involved a massive number of derivatives of that engine. And the cost to do that would have been absolutely immense. So we were in a position of having to distill down the number of engines that we were going to be producing, and quite a rationalisation went on. But one of the favoured routes, therefore, was that we could take a look at hybridisation. Now, having looked at what was going on at Honda and Toyota and the press reception of those vehicles, they were worthy but dull. And that certainly was not for us. We didn't want a dowdy sort of vehicle. There was also a consumer reluctance. Many of those cars and the later ones from other manufacturers, pond in the marketplace. They really didn't get to where they needed to be. So for a sports car, we needed to have a hybrid that was going to stimulate excitement, more excitement than we currently had with the TF, which was already obviously a more exciting car than F, and had gone back to sales figures that were as good as they were at the peak of MGF. It was obviously a good indictment of the TF program itself. So we also had an inkling, more of an inkling really, but we needed to get into the United States with a product. We knew that MGTF at its best probably would achieve around 15,000 units a year, which is good, but not necessarily a sustainable thing. And we knew that there was another 15,000 at least that we could get from the United States if we had a car that was federalised. That meant really we had a crash performance with TF that would meet those stringent and different American requirements. Now we had programs therefore going on to look to see if we could federalise the TF. Not an easy thing to do, and it wasn't until much later that we started to find ways that perhaps could happen. But coming into view also were a number of other sports car options for us, which would have been for a slightly larger car, perhaps more suitable for the American demographic, and a number of projects were started. One that was called Viking, which was a front-engine, rear-wheel drive car with a structure that was somewhat like a Morgan Plus 8. And we had a number of projects looking at different materials for the structure of the vehicle, from Chorus, the steel maker, who were also looking at aluminium, and ProDrive, and our own projects as well, looking at using different forms of carbon fibre and fiberglass, which really were, I guess, in their infancy as far as a volume car was concerned, but a number of opportunities came our way. All of them would have been costly, and perhaps not the right way for us to go at that time, because, as I said at the beginning, the hybrid car was not really on the product plan until later. So our money was being spent on those cars that were going to be high volume and necessary to win the customers that we were looking for. But along came an opportunity for us, which was a godsend. As it happens, Myra at the time were looking to change their business direction from being a test house for the car industry, owned by the car industry, to becoming a standalone engineering consultancy, and we're building an expertise in all areas of car engineering, and as well as doing their traditional things. And it was really through a chance meeting between John Wood, the managing director then of Myra, and myself. And we used to see each other quite often, not only through work but also through play, because both of us were speed hill climbers in single seaters, so we used to see each other at weekends when we were racing anyway. But John indicated that he was very interested in having a real project that they could demonstrate their new skills and show to the industry. And of course we were very interested in building this car ourselves, so it became a joint vehicle between Myra and ourselves, which is a very good way of shouldering the budget responsibilities. So there we were, a small department with Adrian very much part of the important little group of people at Longbridge and a similar group of people at Myra to be able to make this car happen from the pre-concept group, which I like to describe as an official semi-skunk operation. Most car companies have a skunk operation where something goes on under the radar. This was actually going on above the radar, but only just above the radar, and I was finding in our board meetings that sometimes it was quite difficult to justify the kind of expense that we were putting perhaps on this vehicle, which was very ambitious, but nevertheless it was able to happen because Myra were in there with a relatively deep pocket as well. So I'm going to hand over now to Adrian to take on the business case and so on, and I'll come back at the end and talk about the launch of the vehicle.
Thanks, Rob. Yeah, I think the first thing to point out that obviously this could have been supporting a production future, so it was important not only to consider it as just a concept, just a one-off demonstrator, so we had to think about the business case. And as you can see here, we've got the baseline car, and typically for a hybrid, there's obviously an on-cost, and it isn't just the hardware. We have to think about all the testing around the world, homologation and so forth. So hybrids are an expensive proposition. You've got two powertrains in there, and you have to try and deliver as much as you can from that additional hardware and cost. And at the time, as Rob was saying, all of the targets, all of the aims of hybridization in those days was economy, emissions, keep it simple. In those cases, it was a case of here's an engine, I'll nail an electric motor alongside, and that gets the best of both worlds and helps to justify the cost. Our approach was to take a different direction and look at all the opportunities for improving features, drivability, safety, ease of driving in traffic. So you're doing a lot more than just simply saying, you will help the engine get through an emissions test. You're going to make it an exciting car to drive. So we're looking at the possibility of ZEV driving with a sports car. You've got four-wheel drive in a sports car, so it'll help the car's reputation for safety. Oh, and we'll throw in 40 horsepower as well. So all in all, it's a very attractive proposition for the company to sell based on safety first. So really you've got all of this as a guilt-free opportunity to enjoy your sports car. And some of these things, of course, are quite hard to do mechanically. Well, put a four-wheel drive in, well, you pretty well end up tearing up the platform. And we have quite simple proposition with the two subframes. It would be extremely hard to make that four-wheel drive. But just a fat cable from one end to the other, I think we can do that. But the other point of the exercise, we're looking back 20 years ago, was to try and stimulate new suppliers into the supply chain. MG Rover had its existing suppliers and exhausts and all the other components. Out there were very few suppliers able to make high efficiency motors, for example, and controllers. It was all coming originally from an industrial background. We needed to stimulate the UK supply chain, something that had started to happen in Japan, and we wanted this to be a good focus in the UK. So, looking at what we might be able to do, trying to get a bit of customer delight. And I say, the hybrids originally were just an engine and a motor fixed alongside. And we wanted to look at the ways we could harness the controllable, high torque, low speed electric motor, and then the completely opposite characteristics of a petrol engine. So what could we possibly do? And here the option is then, well, rather than keeping the two together, let's have a look. Oh, we can put an electric motor on the other axle. So then you've got completely independent control of the two of them, and that opens up so many opportunities. So there's a potential for four-wheel drive, energy recuperation on the front axle, the sort of thing we see in Formula One. They finally caught us up. So you can get all that recharging by having the motor on the front end. And then you can turn off the engine and just drive on electric only. So there's so many opportunities. So as well as having a blitzing performance, you get into a traffic jam, turn off the engine and trickle along nice and easy in electric drive. So this really offered a great new proposition, and it should have been a great opportunity to make an exciting new car. So, there are some good ideas of all the things we can do with high torque launch, say with the extra traction, hot shift that I'll explain fairly soon. And as I say, the EV city driving. So having the two separate powertrains rather than fixed together gave us a great deal of opportunity. So really, in a nutshell, extended performance rather than superior economy. We were aiming to boost the car without all the penalties that go with it. And keep the fuel economy equivalent to the original car. So that's where the slogan came from. Responsible performance fits very well with safety fast as well. So that was our mantra throughout the program. So one example of improving the performance. This is the hot shift, which you can do when you have two separate powertrains on two separate axles. So this is the acceleration from launch. That left-hand axis, meters per second. So that's your get up and go acceleration. So we've got the standard car in blue, accelerating first, steady into second, steady into third. When you've got an electric motor driving the other axle, during your shift, you can get a continual acceleration, very pleasing driving surge. There we go, hot shift. So that is still continuing to pull the car forward while you are changing gear at the back end. Into second and into third. So you get a lovely surge of acceleration which takes about a second off the 0 to 60 time. So there's one bonus already. So getting into some of the hardware now. Battery chemistry. I think we're all getting more familiar with all of these batteries now. We've got lithium ions and metal hydrides and stuff. But 20 years ago, lithium ion was really the province of NASA. You won't see those in any hybrid or electric cars. There's nickel metal hydride, which the Japanese were using, was well proven, nice and safe. Rob reminded me the other day that another contender was sodium sulfur that MG Rover had looked at 1990, was it, or earlier? Yeah. But that's that is scary battery chemistry. It's got good energy, but you've got to keep this great vat of sodium and sulfur boiling away at about 200 degrees, which takes energy and unlikely to be very cosy if you hit anything. So there were a lot of experiments there with batteries. The French were just weaning themselves off nickel micad, all very toxic ingredients and things. So there wasn't really a right solution at the time, but companies were looking at different routes. And down here, we've got the low lead acid battery. The point with our selection is that along the bottom we've got energy, and up the side we've got power. We're not interested in driving 60, 70 miles on a battery in our hybrid. We want to kick for 10 seconds. We want a power battery. And to its credit, lead acid is jolly good at that. It's good at starting your engine. It's giving a good kick for a short time. The other advantage is you can get them easy. They come in all sorts of shapes and sizes, and precious little battery management. Lithium ion cells, you've just got to plaster it wires to make sure it's all behaving itself. So lead acid was our chosen path. So that's the background on that. So I'll run through basically the layout of the car. So we're looking on the top of the car there, got an engine in the back, you might recognise. So we kicked off with a 160 horse PVC engine and a regular 5-speed gearbox. So we're not changing the engine, which is a good start. Whereas almost every other manufacturer of the day was having to possibly drop down to 3 cylinders or try and fix a motor onto the end and difficulty with packaging. All of that staying the same, so it makes it nice and versatile. So all the blue stuff is our new electrics. As you can see, it's all up at the majority is up at the front end. So at the back, we took out the alternator, 12-volt alternator, and put in a new generator. We're running on 72 volts, so we've got a little generator there. It's called a pancake motor, and I've got an example down here. Tooth belt drive. into the generator at the back. So he's keeping the battery trickle charged as well as when you're regenerating. So at the front, we've got another one of these units, another pancake motor, brushed DC because it's not working for thousands of hours. Got an example, Exhibit A down there, and the attraction with those, very high power to rate ratio, so we can generate 30 kilowatts, that dinky little thing, for about 10 seconds. So it gives you a really good punch. It's air cooled, so you haven't got to worry about cooling pipes and all that shenanigans. The other attraction is stimulating the UK industry. Those are made down in Monitor. So it was a great leg up for a company down near Exeter to get into the auto industry through their little motors. Motor controller, then 72 volt one there. We're talking serious amps. With 72 volts, you've got some pretty fat wires. So it's fine for a short kick, which is really what we wanted. So you won't make something like a Nissan Leaf to run for a long time. Next thing, how to connect this motor, which is it's sort of a low-speed, high-torque motor. You need to connect it to the front wheels. So we found a CVT self-regulating. So we can go into a low ratio when you're getting off the line, and then as you increase speed, it would change ratio. So that little motor could assist up to 60 miles an hour. So that was a convenient find. Lead acid batteries. So we had little 12 volt ones, about the size of a half brick, all connected in strings to get 72 volts. And again, they could do 30 kilowatts for a short kick. Have to look after them a bit, try not to frog them. So at the top, we've got the driver interfaces and so forth. So we've got readouts to the driver, the battery state of charge, the mode selection. So when you came into the city, press the blue button, electric only, and big red button for cutting out of anything that's a bit pear-shaped. So there's all of that to sort out. Little DC-DC converter, because I said we'd taken the alternator out. The rest of the car is running on 12 volts, so what we had was a little converter that takes 72 volts, which is called the power net, because that's all the stuff that's running the motors, and then it drops it down to 12. So the handy thing is then, your little 12 volt battery is another dinky little half brick size, so you do win out of that. And then all the Myra's MathWorks controllers as well. And as Rob was saying, that was an area where Myra were trying to develop their expertise. So this was a great learning opportunity for them, how to make a complete controller for a hybrid car, which was completely off their radar previously. So more homegrown technology. Good. So Myra again in this case, one of the first proving grounds in the country, really set up on an old, like most of them, World War II airfield over near Nuneaton. And that company had one of the very first full-scale wind tunnels going back to the 1950s. So they tested everything from Austin A40s right through our cars as well. So tremendous amount of expertise, front-wheel drive cars, rear-wheel drive, drag, brake cooling, all of these kinds of things that they had a really good knowledge of. So a real godsend of a partner to be working with. So they had tested over their time Fs and TFs, and they had this great library of all the tuning opportunities to reduce the lift, reduce the drag and so forth. So this project again gave them a great showcase to say, well, this is what we can do with a car when we're let loose on it, so to speak, really. So they were big contributors to the increasing performance of the TF, and you probably read some of Rob Bell's excellent articles on all of the aerodynamics. So they have some really good output. So it went in the tunnel. First thing was tackling the lift and drag at the front of the car, and the fundamental change, a bit like busy down there, instead of ducting all the input air underneath the car, it sort of makes it float a little bit at speed. You run it over the top instead, which is quite common practice for a lot of mid-engine cars. So by venting it up and over, you can see the outlets on the top, that helps drag because the air's going really where it wants to, but it helps the lift as well because you're not shoving all the air underneath. So by having the better cooling, we can eliminate the vents at the front, raise the plate as well. It occurred to me, I mean, I've been in this industry a while, I get used to this sort of approach. It looks a bit Blue Peter-ish, but that's actually common practice. That's what you do in a wind tunnel, because wind tunnels are expensive things to run. So you get in there, you make a rod, a mod with duct tape and a bit of cardboard and plastic. Okay, are we on the right track? Okay, we can move on. So you have to keep it simple and expedient when you're in a wind tunnel. So that's the section through the front end that Myra did. So what you can see is the radiator tilted over a bit, and then the ducting inside to take it up over the top. You might say you could have it further back, but we have the battery pack in behind that, so that kind of confined the arrangement of the ducting, but extremely efficient. To balance the car at the end, quite a tidy zip across the back, so that gave a nicely balanced front and rear downforce. And generally looks good again. This shows it off quite well, and we've seen it on the coupe as well. It was shown off the one product development car. So all in all, pretty significant improvements. I mean, aerodynamicists, they bite your arm off for a drop from 0.34 to 0.23. I mean, that's a momentous change. So great opportunity when it helps, obviously from 50, 60 miles an hour upwards. But otherwise, front end, we've got it downforce now. It's not floating on a cushion of air, it's being pushed to the ground. And the back end as well. So altogether, technically brilliant, and it looks pretty good as well, really. We're really pleased with the outcome. They also looked at the cooling. As I say, the electric stuff was working pretty hard, giving it a kick of 500 amps for 10 seconds. So, as we know on the radiator of the F and the TF, the air comes in there and sort of stops, and then it has to go down and underneath. So, Myra used their anemometers in the wind tunnel to verify how much more the air was moving. So the radiator was now doing its full job. Scoop at the back as well to help cool the generator. Something like round the corner there. MGS has got it. What we see has been verified in the wind tunnel, isn't it? That was another bit of their expertise, trying to do thermal modelling. Again, 20 odd years ago, not many people have done thermal modelling, and it was normally a case of heat it up and see what catches fire, really. So with batteries now, they were able to model if it was free convection, well, everything got pretty darn hot. If you put a fan on it, big difference, so the batteries would last longer. So great expertise for Myra from there. So a lot of good science going into this project. You can read all of that. Anyway, it was just to stress that there's a lot more to making a hybrid than just fixing hardware in and putting a button under the throttle pedal. So obviously the controller, which Myra developed, it has to know what you want to do. Are you going to be accelerating? Do you want to slow down? Are you going into a city? Oh yes, okay, we'll press the button and we'll change the driving wheel. Are all the systems happy? Is anything getting too hot? Or is the belt broken or something? All of this stuff the controller is monitoring so that you get what you're expecting to get. It needs to tell you, well, how many battery runs have I got? Because they weren't enormous batteries, and if you kept accelerating and accelerating and accelerating, I've got no more resistance left, I'll be back down to the engine. So the driver needs to know, have I got that extra kick available? So there we are, was the dials that went in. On the left is the state of charge, so you could check all the time how much charge, the boost, and then the having a fright button in the middle, which is common to all prototypes. It wasn't just this hybrid. Right, there's a picture most folk will recognise. I think almost everybody here is called underneath their Fs and TFs. Familiar subframe and the KCs there. So the build at the back end, taking the alternator out, putting the slightly larger diameter generator in, and the mounting brackets for it. Cooling duct coming in from the side there, and a bit of shielding around against the exhaust. So tidy. You know, we're not carving up the old engine bay to do this hybrid job. Very practical. Moving to the front, there's the purple motor at the front, just another one of these, and then connecting down to the CVT that changed the ratio as it increased the speed, and then across to the centre diff, and a couple of metro half shafts out to the side. So very convenient and doable. So that's the front end package, and I think again we got that, as I said in the article, the serendipity of what we started with. We had at the front inherited a subframe which actually is designed to be driven. So we put a motor in, we put some half in, the hubs are right as well. So it made it all extremely doable. So that was attractive, and the fact that as well, when you're building in the workshop, you can drop the subframe out and then do it on the bench, get it all done, and then stuff it back into the car rather than doing the wheels. So in the middle there, you can see the battery sunk nice and low, just that everybody does nowadays, keep the centre of gravity down. So that worked well. And looked quite tidy when it was done. So really nice electric blue, that was the theme of the car, the blue colouring. So the smaller 12-volt battery, so you can downsize and save a bit of weight there. DC to converter in the middle, cut out button on the left-hand side as well. So it all fitted in. Looked very smart when you open the bonnet, because we obviously wanted to impress people. There we are, finished product. Which, as we said, maybe somebody knows where it is, but I fear it's going to be its maker. Not even its maker, really. So it really looks extremely smart. You see the ducting at the front and the lip at the back all looked very professional. The logos down the side to amalgamate between Milo and MG. Interior was all done out of a very smart monogram blue. So it was a really smart prototype to look at. So next stage, obviously, get him out on the track. Now, and this boom again, working with Myra, they've got all the high-speed banking, they've got city routes, wet grip circles, test hills, everything you could possibly need. So you don't need to go on the public road. You can do everything on their test facilities. So yeah, I mean, we've had lots of company engineers and executives come out in the car. And one of the first things really was just that lovely mix. Not only you get blasting acceleration with another 40 horsepower, but then you can come round the corner into the little urban area, press the button, nice and quiet, which is a complete revelation really. So that was a real joy, the response of the car. It wasn't just something else that I can hear a little bit of, or I need to see a screen like you do in a Prius that tells you what's going on. In this one you could really feel it. So it fits in what the brand is about. We did actually make a video, about a 3-minute video. Tim tells me it's on the club's YouTube channel. So if you type in 200 HPD, you should see the video of the car. So about 3 minutes, showing a little bit of the build and the test. But the key bit, which is really impressive to me, we invited John Lyons, who is a sort of professional driving expert, helps companies with the development of their car. And he really enjoyed taking the car out on the wet grip circles. This is low new Bridport pebble, quite slippery, and it's wetted as well. And you could just hold the car opposite lock, round and round. None of this, I'm not sure it's going to go off into the weeds or whatever. So that was wonderful, because you've got the four-wheel drive just helping to guide the car around, 50-50 weight distribution, a bit more polar moments as well, so that made it really steady. So that really fitted the responsible performance bill as well. So the car was on a bit of snow or ice, you really controlled it. So great outcome. So yeah, a bit of a summary of all the deliverables. So all the teams were very pleased with the outcome. Really, we delivered this thing in about 18 months, which is a time scale. Quite a modest expenditure, and a lot of bonus features coming out of it. Really, you say the sort of spin-off as well, and the was encouraging folk into the industry. So, as Rob said, we've got a sort of semi-skunk project, but you never know where semi-skunk projects are going to lead. This was one possible opportunity to take it a bit further forward as a production option. You can see on front axle, we've now got 2 motors. So we've got double the power, which is really nice, but also the opportunity to change the speed and the output torque side to side. And that's got the cachet nowadays, you see in some of the recent released cars, of torque vectoring. It's a brilliant opportunity with an electric motor, so if you're turning right, you can drive the outside wheel a little bit faster, so you've got a quick response. If you start to slide a little bit, you can slow down the inside wheel and put it back straight. So that would be a great opportunity for the car to do the torque vectoring. So we did a design study and a bit of modelling around that. So at the moment that seems to be untapped out there, so we're only 20 years ahead of the car. The other more significant thing it led to is it put us on pole position for the government competition. The Energy Savings Trust in 2004, they launched a competition, you can see on the material there, to all OEMs in the country, so Jaguar, Ford and Vauxhall, to produce a commercially feasible low emission saloon car. So what we did was really take the drive line that were done in the front of the TF and stick it in the back. And we could put it in a 25, we could put it in a ZR, we could put it in a petrol, put it in a diesel. So wonderfully versatile setup really. So we've got the 2 motors there, and got so far we were awarded £4.5 million from the government, which was a useful boost. And we brought in a few more partners as well, so we had Powertrain Limited and quite a few other companies who've been sort of motivated by the TF. So we got as far as the first prototype, actually going down the production line in 2005 to work out the arrangements for getting a battery into the car. So it was a serious advancement. It wasn't just a couple of guys in the shed really. So, but I'm afraid one of the victims in 2005. But I think the other point is that these were unknown to the public, which was disappointing really, and the public had a rather jaundiced view of the company. So, over to Rob.
Right, thanks Adrian, and I think you heard a pretty fascinating tale there of how a very small team, highly motivated team, within quite a small company, certainly quite a small engineering operation, was able to perform something in such a short space of time that had such potential. So how to show it at that point? Well, it just so happened that the Motorsport Industry Association, the trade body for the many motorsport companies in the UK, 400 odd companies, were holding their first clean motorsport conference later in 2003. And Chris Aylett, who runs the MIA, he still does today, he and I used to speak quite frequently about motorsport things, but because of their interest moving towards energy efficiency, as they had to, as the pressures came on to decarbonise all forms of motorsport, he said, had we got anything interesting that we could show at the conference? Well, of course, it just so happened that they had this. So he jumped at the chance, and we were given a very good position in the pecking order of the various presentations that were done that day at that conference in front of quite a large audience of press and obviously lots of motorsport companies and lots of other people who would be interested in this sort of thing. So it just so happens that John Wood, and as head of MIRA, and myself in charge of engineering at Longbridge, were put forward to present the car at that conference, and it went down extremely well because nobody knew of its existence until that point, and it gave us a very good piece of press at that point, which could have led to better things, but unfortunately, as Adrian said, things didn't go the way we wanted them to, and all this technology that had been developed and the opportunities for the future was kind of lost. So that was about it, really. I think we've covered everything that we wanted to.
Well, it did take, sorry,
just
a
one
bit
more
further.
thing.
Yeah, that was the point, really. Having had the launch, there's a great opportunity to showcase the car at many exhibitions, because there are things like the Low Carbon Conference in London, which happens every year, and they've got precious little material to exhibit. So we were made very welcome to bring the car there to showcase what was coming from MG Rover coming over the line. So the car did a lot of tours of different exhibitions. We even had the Minister of State for Energy talk about the car. We gave him an introduction up in London, so it was getting pretty good exposure because it was, such an exciting new proposition that matched the company's brand. And then press launches as well. So it's just great to see responses like that, headlines like that from the press. And I think it was good that they really got it, the idea that we weren't trying to chase after Honda and Toyota and stuff. We were doing our own thing, our own path, in a way that matches the brand and added all this feature that was exciting and production viable as well. We weren't using aluminium here and so forth. We were using very practical everyday materials and dealing with companies. Well, that was really great. So just as a summary, really, one reminder: cars do sell based on customer desires. You need to offer a lot of feature and appeal in your cars. It'd be interesting to see if any hands go up. Anything like that. I'll just conclude on that point really. The team was extremely proud of what they'd delivered. It did lead to a few new opportunities, but I think as well, there were things like excited young engineers about getting into the automotive industry. If you're a graduate, who would want to work on something like that? So there were many other more sort of subtle outcomes from the car. Thank you for your attention and time and Rob, and I think it's just a reminder how we were well ahead of the curve in many areas. Just looking around, I was thinking monogram. That was pretty well, pioneered by the company. Electrically operated engine valves and things, and it just made me think as well, wireless charging of electric cars. Many years later, which team of engineers were the first engineers in the automotive world to fit wireless charging and to test it? It was the engineers at Longbridge, 10 years ago. So BMW was starting to say that they might use it. So more than 10 years ago, wireless charging electric cars, it was being done at Longbridge. So pretty far-sighted bunch, you can brand it.
That's great. Thanks very much, guys. So Rob Oldaker, Adrian Tucker-Peake, thank you.
Right.